This Zoom session is being brought to you by the Fractal Snow Ring. All right, now for today, we'll be doing mathematics of finance. So we're talking about annuities and amortization. In other words, pensions and mortgages. Very grown-up stuff. I have to deal with it all the time. And you'll want to know about this. So we start off with basic compound interest. A present value P grows at compound interest at a rate of I periods, interest rate of I per period for n periods. Its future value, called f, will be p times 1 plus I to the nth power, so an exponential growth. Now, therefore, running backwards, it means that p equals f times 1 plus I to the negative n. This talks up the present value. Bird in hand is worth 2 in the future. So if you have f future birds and the amount of birds grows exponentially, then this is how much that future value is worth at present. So $2 later equals $1 now. If it will probably double in the intervening period. Now, an annuity is a pension scheme. Basically, you make regular payments into a fund. Regular payments are for regular, and you into an account that, first of all, accumulates because you're putting money into it, but also it grows at a compound interest of rate of I per period for n periods, relating in a future value of a sub f. Okay, future value. So here the thing is growing because you're putting money in, and it's also growing on top of that. That's why it's such a why annuities are so popular. You can get startlingly good results. So, for example, now the question is, how much does it grow to? And now we have to make up a formula. So here are $400 payments, 20 payments at an interest rate of 4% per payment, 4% per period. Excuse me, 20 periods, 4% per period, $400. There. So what is the future value? Well, the last payment is worth 400. The next to last is 400 times 1.04 because it grows at compound interest. Second to last is 400 times 1.04 squared all the way up to 400 times 1.04 to the 19th. First payment because it's 19 periods and 0 periods here. So future value equals $400 of 1 times 1.04 plus 1.04 squared plus 1.04 to the 19th power. Now this is a geometric series. And if we go to the formula from last time, the value will be, first of all, 400 times 1 minus 1.04 to the 20th over 1 minus 1.04. Okay, so this grows up to $11,000, which is nice because if you have $400 and then that just times 20 payments, that's supposed to be $8,000. So this is like $3,900 more because of compound interest. So it's, in this case, compound interest is your friend. Now, in general, if R paid n times at an interest rate of per period of I, then the future value will be R, the last payment, times 1 plus R times 1 plus I. The next to last plus R times 1 plus I squared all the way up to R times 1 plus I to the n minus 1. So you get a geometric series, and it's R times 1 minus 1 plus I to the n over 1 minus 1 plus I. This comes out to a negative I. Let's get rid of the negative by reversing things. This should be an I. Excuse me, this is page 3, I. I'll change that in the canvas. And so you get the future value of an annuity is R times 1 plus I to the n minus 1 over I. That's how much it's worth in the future. All right. Okay, that's how much it'll be worth in the future. But, you know, suppose you want something now, like a house to live in or a car to drive. Well, we have something called amortization, whereas you take on a debt now and pay it off gradually by regular payments. Here, the trick is, instead of looking at the future value, you want to find its present value. The present value of that annuity will be A sub P equal to future value times 1 plus I to the negative n, because we're discounting by the amount that it grows. So if you work it out, AP is 1 plus I to the negative n times this thing here, 1 plus I to the n minus 1 over I. After a bit of algebra, you get the present value is R, the regular payments, times 1 minus 1 plus I to the negative n over I. Okay, that's the present value of an annuity. Now, okay, suppose you have a present value that you're looking for. I mean, you have a house with an X, you want to buy a house with a certain value or a car with a certain value. You want to know how many, given the number of payments they're offering and the rate and the interest rate per payment per period, what's the regular amount you must be sending in? Well, okay, you take this formula, you divide, multiply both sides by the reciprocal of this, and that isolates R, and it equals AP, the present value, times I over 1 minus 1 plus I to the negative n. This is the amortization formula. Now, just a small linguistic note. That word amortization is obviously related to mortgage. They both have the syllable M-O-R-T, as in mort, as in death. The idea is that you go into this debt and this huge monster that threatens to grow exponentially. So you throw money at it. And so it's to pay off the a little bit plus the interest rate you accumulate. And again, and keep going at it until it dies. And for me, the death of my mortgage will be in 5 years. Okay, here we go. Anyhow, so this is the formula for the mortgage. This is the formula for present value, and this is the formula for a future value of an annuity. So for example, what is the future value of an annuity of 20 payments, $5,000 each into an account with annual interest rate of 12%? I wish I could get those rates. Well, if for an annuity, for a mortgage, you don't want a high interest rate, but we proceed. Okay, regular payment is 5,000, I equals 0.12, n equals 20. So the future value is R times 1 plus I to the n minus 1 over I. That's 5,000 times 1.12 to the 20th minus 1 over 0.12, and after a certain amount, after some calculation, it's $360,262.21. I must say that 21 cents is probably excess precision. Okay, what is the present value of an annuity? The present value, with 20 semi-annual payments of $1,000 each for an interest rate of 9% per year, compounded semi-annually. Now, because of the semi-annual compounding, you have to divide this 9% by 2. So 0.045 is the interest rate per period. And it's 20 payments, so that's n equals 20. And the $1,000 is R. So you get the present value. Present value is R times 1 minus 1 plus I to the negative n over I. Here it is. Here it is. So 1,000 times 1 minus 1.045 to the negative 20th over 0.045. After some calculation, that's $13,000. Now, it should be noted that we paid $20,000 throughout the whole period to be getting a $13,000 value now. It's a $7,000 difference, which is basically being paid strictly to the bank for the privilege of borrowing their money. So in this case, for present, in terms of present values and mortgages, interest rates are not, compound interest is not your friend. Here we have a $12,000 car paid in monthly installments, so an amortization, a mortgage. Over 4 years, at 1.05% annual interest compounded monthly of the monthly payments. Present value is 12,000 and is 12 months over 4 years, makes 48 payments. Interest rate is 1.105, 10.5% over 12 months per month. So that comes out to 0.00875. So what's the monthly payments? Present value times I over 1 minus 1 plus I to the negative n. That's $12,000 for the payments for the present value. I 0.00875, 1 minus 1.00875 to the negative 48, which comes out to $307.24. Now this times 48 payments makes $14,747.55 paid over time for a $12,000 car. So the $2,747.55 difference, it goes to the bank. It's a finance charge in essence. All right, we proceed. Now here's something that's a problem a lot like what I've been dealing with. 30-year mortgage, $300,000, 4% per year, compounded monthly. What's the total amount paid on this mortgage, and what is the finance charge? The present value is $300,000. The number of payments is 30 years times 12 months per year, 360 months. The interest rate per month is 4% over 12. I'll leave it like that for now. And the regular payment is present value times I over 1 minus 1 plus I to the negative n. That's $300,000 times 0.04 over 12. All that over 1 minus 1 plus 0.04 over 12 to the negative 360. Okay, calculate it out. It comes up to $1,432.25. All right, that's the mortgage, the annual mortgage, sorry, the monthly mortgage. So total paid is this times 360 is $515,000, 608.52. And that minus the $300,000 actual value, the present value, means the finance charge is almost as much, $215,000, 608.52, almost as much paid on interest as on the house. On the other hand, you do get to live in the house in the meantime. I have great fond memories of this particular formula when I and my wife went to buy a house and went to the bank and talked with the loan officer, and the loan officer was giving all sorts of confusing information. Well, so many points off. This interest rate over this blah, 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 all sorts of different things that make a great deal of sense to them, but didn't answer how much per month. Fortunately, I had my calculator with me, and I had the formula. And so, and I gather there are some calculators where they have it this one actually had it pre-programmed, but I had it memorized. And so when the loan officer called me a number, I would go, oh, you'd be asking me for this much amount. Okay, well, how about this, she said. And then I went, well, that'd be costing me more per month. Oh, well, how about that? Sure, that's not bad. At one point, she got so rattled by the fact that I knew what was happening that she said, how about an interest-only loan? And this is a loan which basically goes on forever. I said, you sound like a credit card company. That was rather mean of me, but she was trying to pull a fast one. I didn't want that. So you should know this stuff. You really should. So there we are. And I guess that's it for today.